Countless workers are battling violent ocean currents to complete an underwater structure. But did the chief engineer make a critical error that could lead to disaster? Let's find out. We'll go step by step into the heart of underwater construction using cofferdams. Despite the name, underwater construction doesn't mean working inside water. Modern engineers aim to completely remove water from the work zone. And to do that, the first step is building a temporary watertight enclosure called a coffer dam. This allows workers to operate in dry conditions below the waterline. But how do we build this coffer dam beneath the water in the first place? It begins with guide piles driven into the seabed using a pile driving hammer. These guide piles ensure accurate alignment for the next step. Next, sheet piles are driven into the seabed between the guides. Each sheet pile has interlocking edges that snap tightly together to minimize water leakage. These piles are inserted from the corners and worked inward. This ensures a straight and secure layout. But how do these piles penetrate hard soil and rock? That's where the vibratory hammer comes in. It doesn't push, it vibrates the piles into the ground using counter-rotating eccentric weights. These vibrations reduce soil resistance and allow smooth insertion. All of this is performed from a flat floating platform called a barge, which transports machinery to the site. Before any sheet pile is driven, engineers carry out a detailed geotechnical survey. They test the soil to ensure it can support the permanent structure. The most common method is the cone penetration test, or CPT. A cone-shaped device is pushed into the seabed, sending back data on resistance and friction. A sudden spike in resistance means it has hit bedrock. This tells engineers how deep to drive the sheet piles. With the sheet piles in place, it's time to pump the water out. But wait, why is water still leaking in? Even with interlocked sheets, high differential pressure forces water through gaps. To fix this, engineers use a double-wall cofferdam, placing another layer of sheet piles inside. The space between the two walls is filled with granular material like sand or gravel to resist water seepage. Now the water is being removed again. Everything looks fine. Suddenly, the walls collapse inward. What went wrong? Earlier, water pressure from outside and inside balanced each other. But once the inside was dry, external pressure crushed the cofferdam inward. To prevent this, engineers install bracing frames along the walls. These include whalers, struts, and braces all bolted together. The horizontal struts provide lateral support, preventing inward failure. With the structure now secure, it's time to excavate the soil inside the cofferdam. This is done using clamshell buckets controlled by a crane, simple but effective. Once the soil is cleared down to bedrock, engineers construct a concrete seal course. Before that, they drive hollow steel pipes into the bedrock and clear them using an auger. Reinforcement bars are added and concrete is poured to create a stable foundation. To pour concrete underwater, engineers use the Tremy Method, a pipe with a bottom plug to keep water out. Once the pipe reaches the bottom, it's jerked slightly so the plug drops and concrete flows smoothly. The pipe's end is always kept submerged to avoid mixing with water and to ensure solid bonding. With the seal course ready, workers begin assembling the reinforced bar skeleton for the bridge pier. They pour high-quality concrete, letting it cure for 14 to 28 days for full strength. Once cured, the cofferdam is no longer needed. It's removed. However, the sheet piles are cut just above the concrete seal course to maintain foundation integrity. And there you have it. The bridge pier is complete, ready to support a massive structure above the water. This is just one type of underwater construction. Other methods like caisson foundations and pile foundations offer different solutions.